So this lesson is on graphic equations in which we will find the slope and the y-intercept. So the objectives are to find the slope of a line given the coordinates of 2 points on the line. Then we're going to graph the equations that are written in the standard slope-intercept form, which is y equals mx plus b. So what is slope? Positive slope goes up, negative slope goes down. It measures the steepness of something or the amount of slant of it. And it is written y equals mx plus b. It is written with the m as slope. Rise over run is another way to do it, or to describe it as the change in y over the change in x. So the change in how high or low you go, which could be positive if it rises, or negative if it drops. Over the run, positive if it goes this way, negative if it goes that way. So with this slope here, it goes to the right and up, so it is positive. This one is negative because it goes down into the right. So it would be a negative over a positive, which would be a negative. So what does a line look like when you have a positive slope? It looks like that, like you're going up a hill. When you have a negative slope, it goes down, like you're going down a hill. Zero slope, or a slope of 0, means it's flat, meaning you compare points over here to points over there, and all points are on the same plane. They're all flat. And finally, if you have no slope, it is undefined. That means the slope is over 0 in a fraction. The run is 0. There is no run. And that would be a straight up and down slope. So that means it has no slope, because you can't compare one place to another one and say that it changes, as you can see. So definitions of slope. One is the tilt or inclination of a line, how it goes up or down over a time period. It is also called a ratio of vertical change to horizontal change. The rise, vertical, over the horizontal, the run. Or a change in x over the, or change in y over the change in x. So, as you see, here's your graph, y equals x minus 2. So your graph looks like this. It is written in your standard slope-intercept form. Compare that to the graph of 1/2 x minus 2. Now, in the first one, we see that there is no number in front of this x. That means there's an imaginary 1 there, 1x, because that's what that is. That is 1x. This one is half an x. So the 1x has a steeper slope than the half x. So the smaller the number, and we know half is smaller than 1, half being smaller than 1 means the slope is flatter. It's more gradual. If I had posted a slope of 8x, it would be a lot steeper, much steeper line than either of those two. So notice, the smaller the slope, the smaller the line becomes flatter. Now let's compare it to 2x minus 2. As you can see, there's a 2 in front of the x, so that means the line, the purple line, is much steeper than the teal line or the blue line. Larger the slope, the steeper it becomes, and that is misspelled. I didn't create this PowerPoint. So let's consider y equals x plus 2. There it is right there. Now, when x is positive, and here it's positive, there is no negative in front of the x, so it is a positive graph. It goes uphill from left to right. As compared to y equals negative x minus 2. What's going to happen with it? It's going to have a negative slope because the x is negative, the graph goes downhill. So we're going to look at this concept of determining slope. Positive slope goes up, Negative slope goes down. Negative slope is a downer, while zero slope is flat, and no slope or an undefined slope is straight up and down. So you have to do work to go up a positive slope. So that's why it's positive. You go down the hill, you don't have to do any work, or you do less work. So it's a negative slope. When you get to a flat place, zero slope is fun because you don't have to hang on for dear life and you really don't have to work. You just kind of go along. But then you get to the undefined slope. And an undefined slope means you just go straight on down. So, how do we determine slope? First, you have to pick 2 points on a line. The points need to be where the lines cross so that we have exact whole numbers and not not fractions or decimals. So we find the rise first, how high or low it goes. Then we find the run. Then we determine if that slope is positive or negative. So here we have a point at -1, positive 1, 2, 3, 4, 5. So -1, because we always start at 0, 0, -1, positive 5. And the other point is at positive 2, positive 3. So we discover that we actually go down on our rise. Our rise is down, and then our run, though, is positive. So because this part is negative, it's a negative over a positive. And if we remember that from dividing signed numbers, a negative divided by a positive will give us a negative. So this is a negative slope because the rise is -2. Even though the run is positive, it's a -2 over 3. Slope is rise over run. So it's 2 over 3, but it's a -2 over 3 because it declines. It's going downhill. So let's look a little more at slope. Pick 2 points that actually cross. So if I'm looking at this one, I see a point that could be there. I could do a point there. I could do a point there. Or I could do a point there. Just 2 of those. That's all you need. So we're going to pick 1 point, and 1 point is going to be at positive 1, 2, 3, 4, 5, 6. So the point is 1, 6. The other point will be at -1, because we're going back from 0, 0. -1, -1, 2, 3, 4. So -1, -4. So just looking at this, we can see you've got to go up the hill, so it's a positive slope. So let's count it out and let's see what we got here. This example actually starts from the second one. It goes down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It goes down 10. So the rise is 10, or the -10, if you want to look at it that way. And then the run goes back 1, 2, negative, because it goes back to the left. So if I'd said -10 over -2, it's the same as positive 10 over positive 2. And rise over run is 10 over 2. So it could have been -10 over -2 or positive 10 over positive 2. 10 over 2 or 10 divided by 2 means 5 or 5 over 1. Sometimes it's just written as 5, but 5 still means 5 over 1. So for every 5 I go up, I make a run over of 1. So don't forget that, even though it says the slope may be a 4 or a 3 or a -2, that means always over 1. So here, with horizontal lines, we see because the rise, there is no rise, and the run could be on forever, that it's 0 over whatever, 0 over 3, 0 over 4, 0 over 8. So it's 0 over whatever, which is just 0. as opposed to a line that goes straight up and down. The run could be 0, but the rise goes on forever. Because it's over 0, it's undefined. Any fraction over 0 is undefined. So, let's look back over this. So in the slope-intercept form, the slope is what's right in front of the x as long as the formula, the equation itself, has y by itself. As long as y is by itself, which we'll solve for y by itself later on, then it equals slope times x, whatever x is, plus the y-intercept. So m is the slope, b is the y-intercept. So any equation that's written in the slope-intercept form, which means it's solved for y, m is going to be slope, y is going to be the intercept. So let's look at a few of these. So let's find the slope and y-intercept of the following. Now first we check both are equal to y. So we're good there. So it's 3x plus 4. So the slope is going to be 3. And the y-intercept is going to be 4. Here, y is all by itself, so y is equal to negative 2x minus 2. So the slope is negative 2, and the y-intercept is negative 1. Ooh, now we get to a little more difficult one. But still, same thing. Y has already been solved for, so y is equal to mx plus b. So m, slope, is negative 2 over 9. And b, the y-intercept, is negative 1/4. Because that subtraction sign means negative. And then finally, they did this one wrong. So if y equals 5x, that means the slope is 5. And because there is no b, there is no y-intercept, that means it's equal to 0. So make sure the equation first is in the slope-intercept form, meaning that y is equal to mx plus b. Find the slope and the y-intercept. Then you plot the y-intercept where it crosses y, the one that goes up and down, and then apply rise over run to the y-intercept. So let's use this concept. So because the intercept, or the equation, is y equals 1/3 x plus 2, we know that the line will cross the y-axis at positive 2. That's the y-intercept. And that's the first thing you do. From the y-intercept, we apply rise over run using our slope formula. So we'll rise 1, but then we're going to run backward 3. So our line can go up 1, rise, and then over 1, 2, 3. Or you could have gone down 1 and then forward 1, 2, 3. So the line will go this way. We know this because either you go down 1 and then positively 3, or up 1, positively 1, and negative 3. So it'll go this way. See the example here, it goes up 1 and then negatively 3. So repeat this again until you get to the new point, and you can keep on going with these points, and there's your line. So let's graph y equals 3/4 x minus 2. Here's minus 2 right here. So we know that number, when we set it equal to y, the number standing by itself is negative 2, right there. Now we'll go up 1, 2, 3, because that's our rise. Rise comes first. And then our run, which is 1, 2, 3, 4. So our other point will be right there. Let's see. The equation's already in slope-intercept form. That's good. So the y-intercept is negative 2, or 0, negative 2, which is where it crosses the y-axis. That's what the y-intercept is. So the slope, they did it this way. They went over 4. Our run is 4 and our rise is 3. So the second point will be at 4, 1. Because that would be 4 over and then 3 up. So that's 4, 1. And then you just graph the line. Just like that. And that's it.